Hey guys, welcome to section 4, chapter 4 of the pre-algebra program. And I got another short video for you today, and we're going to have another short video tomorrow because chapter 4 really is a lot of review and kind of a nice reprieve from all the challenging things we did in chapter 3. So I don't think that there needs to be a ton of instruction, but I just want to make sure that you guys are ready to go for your assignments. And yeah, we'll just do some examples for you here of finding the greatest common factor using what we just learned, the prime factorization. So this is a very handy tool, and hopefully you guys will find it pretty easy to get through. Okay, let's say I want to find the greatest common factor of 6 and 8. Okay, these numbers are small enough. Hopefully you guys are looking at this and thinking, oh, well, the biggest thing that goes into both of them, of course, is 2. But I'm going to show you how we would find that using prime factorization, and then we'll use a few bigger numbers here. So if I did the prime factorization of 6, I would get 2 and 3. And then if I wrote the prime factorization for 8, I would get 4 and 2, and then 2 and 2 in my nice little factor trees here. And then once I have each number down to all primes, basically what I'm looking for is the primes that they have in common. So this guy has a 2 and this guy has a 2. So I know for sure that they both have a 2. But then this guy has a 3. And 8 has 2 more 2's, so the only thing in common is that first 2. So the greatest common factor of 6 and 8 is 2. All right, not too hard, I don't think. Let's do another example with numbers that are a little bit bigger, maybe a little bit less obvious. What about 21 and 45? So we're going to use factor trees to write the prime factorization. For 21, I would just break that down to 7 and 3. Both 7 and 3 are primes, so that guy is done. And 45, I'm thinking 9 and 5. And then 9 can break down into 3 and 3. And now 45 is in all primes here. So I look for the ones that they have in common. 21 has a 3 and 45 has a 3, so he's a winner. But then 21 just has a 7 and 45 has a 3 and a 5. So again, the greatest common factor here for 21 and 45 is simply 3. All right, let's see if we can do a harder one than that. What if we have 36 and 72? So we're going to do factor trees for both of these guys. Let's do 6 and 6 for 36. 3 and 2. 3 and 2. All right, 3 and 2 are both primes, so he's good. In 72, I'm thinking 9 and 8. But again, any combination works here whose two numbers multiply to 72. Those are just the ones that kind of jumped out at me. 4 and 2 for 8, but then 4 is not quite done. He can get down to 2 and 2. Okay, so now we have several factors in both, so we need to be careful. Let's start with he's got a 2 and he's got a 2, so I'm going to write that over here. And then he's got another 2 and he's got another 2, so I'm going to write that over here. And then 36 has a 3, 72 has a 3. And then we have one more 3 that's going to match up here. All right, 36, we've used all the primes there, so we can't go any farther. Now, when you have multiple numbers here, we're going to multiply them together. So 2 times 2 is 4. 3 times 3 is 9, and 4 times 9 is 36. So the GCF here of 36 and 72, of course, is 36, because 36 times 1 is 36, and 36 times 2 is 72. All right, there's one other curveball here in these problems that I want to bring your attention to. There are a few problems that actually have letters in them. That's right, folks. It's pre-algebra, so couldn't be pre-algebra without throwing some letters in there. But do not fret. It adds one tiny little step to our prime factorization, and hopefully you'll find it to be pretty easy. So again, to find the GCF of these two terms now, I'm going to start with my factor trees and prime factorization. So for 14, I would break down to 7 and 2. And those are both prime, so there's no place else we can go. And then for 42, what about 7 and 6? And then 6 can break down to 3 and 2. All right, so now with our letters, remember in the first section in chapter 4, we learned about our exponents. And when there isn't an exponent, we assume it just means 1. So this guy has just one n. But this guy, n squared, is the same thing as having n times n. So just like with our numbers, we're looking for what we have in both. For our GCF, like they both have a 2. For our letters, we're looking for what they both have in common. He has an n and he has an n. And so my greatest common factor here is 2n. Wow, I completely missed the 7. So let's go back and do that again. That was awesome, because I was so focused on my letters. Good, that was like a good trial. Get me started. Yowzers. It's because the kids interrupted my nap today. Okay, in this next example, don't fret. I know that we have letters involved, but of course it's pre-algebra, so it wouldn't be pre-algebra without a few letters in there. But we're going to start the exact same way. We're going to start with our factor trees and prime factorization for each of our numbers to get us down to primes. So for 14, of course, that just breaks down to 7 and 2, both of which are prime. And then for 42, we can break that down into 7 and 6, and then of course 3 and 2. Now we have all primes here. So just like before, we're going to look for what we have in common. Like he has a 2 and he has a 2. So we're going to write that down here. Maybe. And then also he's got a 7 and he's got a 7. So we're going to write that. All right, now we have to contend with our letters. And remember in the first section, we learned about our exponents. And when there wasn't an exponent, we assumed that the exponent was a 1, meaning I simply have just one n here. But in this case, n squared, remember, denoted 2 n's. That's how we wrote 2 n's. We wrote them as n squared. So now each of these terms have an n. So I'm also going to write down an n for my GCF. And then simplifying, I get 14n. That is my greatest common factor. Okay, I'm going to do one more example here with letters just to make sure you guys feel comfortable. I'm going to have 36a cubed and also 56ab squared. Okay, 36 breaks down to 6 and 6, and then 3 and 2, 3 and 2. All right, my letters, if you want to just jump right into that, a cubed means I've got 3 a's there. All right, and then 56, I don't know, I'm thinking 8 and 7, 4 and 2, and then 2 and 2. Now we're all down to primes there. Okay, now my letters, I have an A, and it looks like I have 2 B's because my B squared, right? Okay, so now just you have to be slow and methodical here to make sure that you've matched up appropriately. So he's got a 2 and he's got a 2. I'm going to write it over here. I'm not sure if circling or crossing out is better. I think probably crossing out. All right, it looks like 36 has another 2, and so does 56. So I'm going to do another one of those. All right, and what I have left here is a 3, a 3, a 2, and a 7. So my primes are done for my numbers. Now I'm going to look at my letters and find out what I have in each. Well, it looks like I simply have an A.